Hello, am I audible? Atif, Yusuf?
Yes, sir.
Okay. So in last class, we had just started flow of liquid, in which I have first defined you about laws of viscosity. So do you have any doubt from last class?
No, sir.
Okay. So related to this particular viscosity, we may define flow of liquid. So types of flow of liquid. Suppose you have a tube of variable cross section like this. So area of this end is A1. Area of cross section for this end is A2. If velocity of each layer of liquid at this point is V1, it will be possible only if there is no viscosity between layer of liquid, or there will be no viscous force acting between layer of liquid. Similarly, at this cross-section area, velocity of each layer is V2. So this particular type of flow is called streamline. And this particular flow will be possible only if liquid is non-viscous. Next is it should be incompressible. It means density of liquid at each instant will be same. And next, it should be irrotational, that there is no rotational property of liquid at any instant due to flow of liquid. So this type of flow is called streamline, or you may say ideal flow. Yusuf, is it clear?
Yes, sir.
Now, suppose there is a tube and in which there is viscosity between layer of liquid. So in this part, centralmost layer will move with maximum velocity. And as you move alongside, so there will be opposition to this particular flow of liquid due to its adjacent layer as well as due to its boundary. Similarly, on this direction, so velocity on edges will be least as compared to the centralmost part. So this type of flow of liquid is called laminar flow. Third, suppose there is a tube and in which velocity of each layer is irregular. Due to irregularity in velocity of each layer, suppose this layer will have some velocity v and this adjacent layer will have some greater velocity as compared to this. So it may get spiral at this point since there is no any matter at this point. So it may get a spiral. Similarly, this may get spiral this, and so on. So this spiraling behavior of fluid is called eddy formation. And for the flow of liquid in which there is formation of eddies is called turbulent flow. So in laminar part, there is viscous force between layer of liquid and also opposition due to wall of tube, due to which the edge layer will move with least velocity and central layer will move with maximum velocity. In this turbulent part, each layer will have different or uneven velocity due to which it may get spiraled at any vacuum part. Each different layer may have uneven velocity. So may get spiraled to form eddies. So this type of flow is called turbulent. So we mainly have these three different types of flow of liquid. Abhinav, is it clear?
Yes, sir. Clear, sir.
Just write it down till this part.
Yes, sir.
Sir, can you explain turbulent flow again?
In this turbulent flow, if there is irregularity in velocity of each layer, or there is uneven velocity between each layer. So if this layer is moving with some velocity v, let's say this adjacent layer may have some greater velocity. So it's moving along this direction till this point. So there will be some vacant space at this point, due to which it may move along this point and may get spiraled at this. So this spiraling behavior is called eddies formation. In some other sense, you will say, if there is obstacle at this point, so this layer may get hit at this point and may get stopped. And this adjacent layer may move ahead and got a vacant space at this point, so make it spiraled. So this spiraling behavior of flow of liquid is called eddy formation, and this flow of liquid is called turbulent flow. Atif, is it clear?
Yes, sir, it's clear.
You all have written?
1 minute.
Okay.
Done, sir.
Yusuf, you have written?
Yes, sir.
Okay. Now, related to these different types of flow, scientist Reynolds defines a specific number on the basis of which we can assign these different types of flow. So let me define you about Reynolds number. It signifies the type of flow related to some specific number or on the basis of some specific number. Suppose you have a tube having diameter d, in which a liquid is flowing in a streamlined condition, for which velocity of liquid is called critical velocity. So let's say velocity of liquid for this streamlined flow is called critical velocity. Density is rho and coefficient of viscosity is eta. So first in this part, the velocity of flow of liquid for which it behaves as streamline or ideal flow. So this is called critical velocity. Now suppose this critical velocity may depend upon three different factors. First, density of liquid. Second, coefficient of viscosity. And third, diameter of this particular tube. Consider critical velocity Vc of liquid depends upon density of liquid, that is rho, coefficient of viscosity, of liquid, that is eta, and last, diameter of tube. So on the basis of this relation, we may use the concept of dimensional analysis, which you have learned in chapter number 2, deducing relationship related to a different physical quantity. So using that concept, we have to derive a relation. So let me define you how to calculate. In this part, we have to calculate critical velocity. That is the quantity which we have to calculate. Next is depending factor. First is density of liquid. Next is coefficient of viscosity. And third is diameter of this tube. So we can write first critical velocity having depending factor density, coefficient of viscosity, and diameter. So relation of this critical velocity related to these three different terms would be either directly proportional or inversely proportional, and with some raised power also. So we can write critical velocity proportional to rho to the power x, eta to the power y, and diameter to the power z. Now, if you remove this proportionality sign by any constant of proportionality, let's say Vc equals to some k rho to the power x, eta to the power y, and diameter to the power z. Now you got a formula like this. Now, according to this, write the dimension of each term on left-hand side and right-hand side, then compare the exponent of same term on either side to get x, y, z. First, write it down to this part, then I'm calculating this. You all have written till this part?
Yes, sir. Written, sir.
1 minute, sir.
Yusuf, done?
Done, sir.
Okay. Atif, any doubt till this part? Mohammed Irfan,
Yes, sir.
do you have any doubt?
No, sir.
Okay. So we can write dimension on either side of this particular equation. Dimension formula of this velocity will be m0 L t to the power -1, k being proportionality constant, so it will be dimensionless term, so just neglect it. Rho, which is density, so mass divided by volume to the power x. Eta, coefficient of viscosity, so it will be ml-1 t-1 to the power y. D, diameter is nothing but length, so it have exponential z. Now take out exponent of same term together. We have m to the power 1 to the power x, so it will be x, and at this part it will be y. L having exponential -3, so it will be -3x, and this part it will be minus of y, and this part it will be plus z. And last, for t, it will have minus y only. Now just compare the exponential of each side of same term to find x, y, z. Try to find and send me your answer. Just compare the exponential of same term on either side. Exponent of m with exponent of m, exponent of L to the exponent of L, and so on. Atif, you got any answer? Irfan, just check your calculation. On comparing the exponent Riba, check your calculation for Z. Rest is correct. Yes, Irfan. For M, we have X plus Y on right hand side. And left hand side, we have just 0. Good, Irfan. For L, we have minus 3x minus y plus z equals to 1. And for T, we have minus 1 equals to y. So this minus 1 and this minus will cancel out. So you'll get y equals to just 1. Now put this value in first equation. You will get the value of x. Then put these two values in this middle equation. You will get the value of z. Atif, is it clear?
Yes.
Try to simplify. Abhinav, send me your answer.
Yes, sir.
Yusuf, you got the answer?
Yes, sir. Sending.
Okay. Atif, just send your answer.
Sorry, send.
Good, Yusuf. If you put the value of y in this first equation, it will be x plus 1 equals to 0. So on moving x to the other side, it will be minus 1. Now put the value of x and y in this middle part, you will get minus 3, x is minus 1, minus y, y is 1, plus z equals to 1. So this will be minus 3 minus 1. So it will be plus 3 minus 1 plus z equals to 1. So it will be 2 plus z equals to 1. So z will be minus 1. Yusuf, Is it clear?
Yes, sir.
Adif, any doubt?
No.
Now, we have to put these values in above formula and replace the value of K by a constant term that is called a Reynolds number. So K equals to RE. Therefore, V equals to K, that is RE, Reynolds number, rho to the power X, which is -1, eta to the power Y, which is +1, and diameter to the power Z, which is -1. So on rearranging, it will be RE eta divided by rho times D. Move all terms towards left hand side to find RE. So you will write RE equals to rho VD by eta. So this will be a final expression for Reynolds number, which is a constant numerical part related to which we can define types of flow of liquid. Irfan, is it clear?
Yes, sir.
Okay. Now, on putting the value of rho VD, Reynolds number will be less than 1000. So for this, flow will be streamlined. If Reynolds number is in greater than 1000 but less than 2000, so it will be laminar flow. If Reynolds number lies in between 2000 and 3000, so it will be unstable between laminar and turbulent. And if Reynolds number is greater than 3000, so it will be turbulent. Is it clear to all of you till this part?
Yes, sir.
Okay.
Yes, sir.
Just write it down from this part.
Done, sir.
Okay. Rishan, you have written? Mohammed Irfan,
Sir, 1 minute, 1 minute. Yes, sir, over.
okay. Let me give you a problem related to this. A tube having a radius 5 centimeter in which water is flowing at 10 centimeter per second. If eta is 0.05, find Reynolds number and define type of flow. Density of water is 10 to the power 3 kg per meter cube. We have radius as 5 centimeter. So diameter will be twice of it. So it will be 10 centimeter. If you convert it into meter, it will be 10 to the power minus 1. Velocity is 10 centimeter per second. So just convert it into meter. So it will be 10 to the power minus 1 meter per second. Eta is 0.05 Pascal second. And rho is 10 to the power 3 kg per meter cube. So just use the formula Re equals to rho Bd by eta. Put all the values in this equation and simplify it. Good, Atif. Abhinav, you got the answer? Yusuf,
1 minute, sir.
Mohammad Irfan,
Sir, did you call me?
yes, you have solved this.
Sir, doing. That's why I was.
Okay. Good, Riba. So which type of flow it would be? Riba? Good. We have rho 10 to the power 3, V 10 to the power -1, D 10 to the power -1 by eta 0.05. So remove this decimal and write 100. So this 20 and this 20 will cancel out this part and this part. So you're left with 1000 divided by 5. So it will be nothing but just 200. So which is less than 1000. So flow will be streamlined. Irfan, is it clear? Yusuf?
Yes, sir.
There is another way of calculating this Reynolds number. In some time, it will be asked in terms of the rate of flow of liquid. So let me define you about what do you mean by rate of flow. Rate of flow of liquid is amount of or volume of liquid flowing in a tube per unit time. So rate of flow of liquid is denoted by Q. We can write volume as area into length divided by time taken T. So this length per unit time may be also called velocity. So it will be area into velocity. Is it clear? Atif?
Yes, sir.
So we have to calculate velocity from this part and put it the above for Reynolds number. So velocity will be equals to Q divided by area of cross section. Since tube, which is circular in shape, or cross section area will be circular, so area will be pi r square, but we are dealing with diameter, so we can write pi d square by 4. Now put this expression in the above formula. Therefore, Reynolds number equals to rho v 4q by pi d square times d divided by eta. So this t and this t will cancel out. So you're left with 4 rho q divided by pi d eta. So this is another way of expressing Reynolds number. Muhammad Irfan, is it clear?
Yes, sir.
You'll be asked another question related to this. To define Reynolds number in terms of force. Suppose Re equals to rho Vd by eta. We can write rho. Rho is density. Density is equals to mass divided by volume. Mass divided by volume. Velocity equals to, if initial velocity of object is 0, so we can write according to equation of motion, v is equals to at. D is diameter divided by eta. So this will be mass times acceleration. We can write volume divided by time as area times velocity according to this above relation. So we can write volume divided by time as A into V into eta, and this diameter, just 1 minute. Volume is A times X into eta. Diameter is in numerator, so we can write it into denominator of this part times T. Now in numerator part, we have mass times acceleration. So this is called inertial force. And in denominator part, we can rearrange it like A times eta times X by T is velocity times D, that is width of that particular tube or liquid. So this may be written as strain rate. So it is equal to viscous force. So you can write this numerator as inertial force and this denominator as viscous force, which we had defined for law of viscosity. So we can write Reynolds number is a ratio of inertial force to the viscous force. Atif, is it clear?
Yes.
Okay. So we mainly have three different relations for this Reynolds number. One is in terms of rho Vd by eta. Second, in terms of rate of flow of liquid, Q. And third, in terms of this force. So we may be asked related to these three different situations. Just write it down. Abhinav, do you have any doubt till this part?
No, sir, no doubt.
You all have written till this part?
Yes.
Mohammed Irfan,
Written, sir.
okay. Next term is, in this part, or law of viscosity, we have defined the amount of viscous force or opposition force caused in between layer of liquid. But now suppose if a body is projected in a viscous medium, so how much amount of viscous force will be experienced by it? So it is defined by another term that is called Stokes Law. So Stokes' law simply states or define the amount of viscous force experienced by any object moving in a viscous medium. It defines the amount of viscous force experienced by a body moving or projected in a viscous medium. Suppose this viscous force experienced by a body, let's say this is spherical ball, is projected with some velocity v in viscous medium. So viscous force experienced by this particular object will be in opposite direction of its motion. So let's say along this direction. So this viscous force will depend upon some factor of this liquid. The viscous force experienced by body depends upon coefficient of viscosity of liquid, that is eta. Next, radius of this ball, we just assume spherical shape of this particular ball, so it may have same curvature from all its side. Next is velocity of body, v. So on the basis of this dependency, we can write according to dimensional analysis concept as force viscous equals to some constant k dependency over eta to the power x, radius to the power y, and velocity to the power z. So this will be a general empirical relation between these terms like this. Now, write the dimension of each term on either side. Force, velocity, eta, and compare the exponent of each term. So let's say for force, dimension formula is mlt minus 2. M raised to 1, L raised to 1, T raised to minus 2. K is proportionality constant, so it will be dimensionless term, so just neglect it. Eta, M, L minus 1, e raised to the power minus 1 to the power x. R being length, so it will be L to the power y, velocity L to the power minus 1 z. Rearrange it, you will get m to the power x, L to the power minus x plus y and plus z, and t raised to minus 1 minus z. Now just compare the exponent of each term on either side to find the value of x, y, and z. Try to find and send me your answer. Atif, just check your calculation. There is a little mistake. Check your calculation, Atif. Just take out x just take out -1 to be common from each side and then put the values. Riba, you have solved? Mohammed Irfan? You got any answer? Okay, next. Yusuf, send me your answer.
Okay, sir.
Just see, on equating the coefficient of exponential of m part, we have m to the power x. Yes, Irfan. Good, Yusuf. So x will be equals to just 1. In second part, we have -x plus y plus z equals to 1. And third part, we have -x minus z equals to -2. So we have already x equals to +1. So take out minus as common from this part. So you're left with x plus z equals to -2. So this minus and this minus will cancel out. Now put the value of x to be 1 plus z equals to 2. So z will be equals to just 1. Atif, is it clear? Good, Riba.
Yes, sir.
Now put the value of z in this third part. So -1 plus y plus 1 equals to 1. So this minus and this plus will cancel out. So you will get y equals to just 1. Now put the value of k to be 6 pi in this expression, which is calculated experimentally. So you can write viscous force equals to 6 pi eta to the power 1, r to the power 1, and velocity to the power 1. So this will be your expression for viscous force experienced by any object moving in a viscous medium. Now, for this expression, this term from this point to this point, 6 pi is a constant term, eta is a constant term for this liquid, radius of object is also constant. So these factors will be responsible for opposition caused in that particular object. So this is also called damping factor. The factor which causes opposition to that movement is called damping factor. So maybe denoted by B or sometimes gamma. So we can write this above expression as F equals to B times V. And since this force is opposing in nature, so there will be negative sign with it. So you can say viscous force will depend upon velocity of object only, and rest of the all term will be constant. Is it clear? So this force or viscous force experienced by that particular object may be called as drag force. Atif, any doubt?
No, sir.
Okay. Mohammed Irfan, is it clear?
Yes, sir.
Abhinav Rana, do you have any doubt?
No doubt, sir.
You all have written till this part? Mohammed Irfan,
Yes, sir.
you have written?
Yes, sir.
Okay. Now there is application of this particular force, or on the basis of this force, we may define a term that is called terminal velocity. There is also an experiment related to this velocity in your course. Suppose there is a body which is dropped in a viscous medium. So if a body is projected in a viscous medium, so it may experience viscous force which will oppose its motion. So its velocity may continuously will decreasing. At some instant, net force acting on it will be zero. Suppose this object may acquire this position. So if you define all forces acting on this particular object at this instant, so first there will be a force in downward direction, that will be weight of object due to gravity, and to overcome this particular weight or due to this liquid, there is opposing force along this direction, that will be buoyant force. And since it is going downward, so there will be some viscous force along this direction against its motion. So if net force acting on this object at this instant is 0, so this body will move with some constant velocity in this viscous medium. This constant velocity with which a body may ascend or descend in a viscous medium is called terminal velocity. So terminal velocity is the constant velocity with which a body will ascend or descend. It may depend upon density of object and density of medium, related to which we may define weight is enough to overcome that bound force, or bound force is enough to overcome that weight. So it may ascend or descend in viscous medium. Is called terminal velocity. Since in this part we have some constant velocity, which means acceleration of body will be 0. So velocity is constant. So acceleration of body will be 0, or you can say net force acting on this particular body at this instant will be 0. Now we have mainly 3 different forces acting at this instant. So total upward force must equals to total downward force. Viscous force equals to 6 pi eta r times v. Buoyant force is nothing but density of medium times volume times gravity. Weight of object is density of object into volume times gravity. Now move this term to right hand side and calculate for this v. So it will be 2 times of r square by 9 times of eta bracket sigma minus rho times gravity. Or in terms of mass, you may write it as mg divided by 6 pi eta r bracket 1 minus rho by sigma. So you may learn this terminal velocity in terms of mass or in terms of this. Is it clear? Atif, any doubt till this part? Okay, first write it down till this part. Then I will define you the different condition related to this terminal velocity.
Right.
You will have written.
Yes, sir. Done.
Okay. Now, on the basis of this density, we may define three different terms. First is if sigma, that is density of object, is greater than density of medium. So terminal velocity or V will be positive. It means object will tend to go down or it will descend. If sigma is equals to rho, so the difference of these two terms will be zero. It means it will remain at its equilibrium position. And third, if sigma is less than rho, it means V will be negative. So it will start ascending. There is a graph related to this. Suppose this is your terminal velocity, constant velocity. So if you drop a body in a viscous medium, so it may attain terminal velocity after some time or after some height. So graph for that will be like this. In this part, initial velocity is 0, which is smaller than its terminal velocity. Suppose another object which is dropped downward with some velocity but less than terminal velocity. So it may attain terminal velocity at this instant. So it will have velocity greater than 0 but less than terminal velocity. In some other case, if it is projected at greater velocity than its terminal velocity, then its velocity may start decreasing to reach at this level. So initial velocity is greater than terminal velocity. So a body may attain terminal velocity in these three different conditions. And I'm defining this velocity versus time or versus height. Atif, is it clear?
Yes.
Mohammad Irfan, any doubt?
No, sir.
You all have written?
Yes, sir.
No. Mohammed Irfan? Okay. Let me give you a question related to this. Find terminal velocity of air bubble in water of radius 3 mm if eta is 0.05 Pascal second. Take gravity to be 10. Density of air is 1.3 kg per meter cube, which is very small as compared to density of water. So you can just neglect it. Now use the above formula and try to find. Radius is just 3 mm. So just multiply it by 10 to the power minus 3. So it will become in meter. Eta is 0.05 Pascal second. So according to the formula, V equals to 2 times R square by 9 times eta. Density of object minus density of medium times gravity. So just neglect this particular rho, sigma, in comparison with rho. And now put all the values. So it will be minus of 2R squared rho g by 9 times eta. This negative sign of velocity mean object will be ascending. It means the bubble will rising up. Is it clear?
Sir, why did you remove sigma?
Just see the value of sigma, which is 1.3 kg per meter cube, and value of rho is 1000. So in terms of 1000, 1.3 is very small So we can neglect it.
Okay.
As there will be no any much impact on that density. Yusuf, you got the answer?
Yes, sir, I'm doing it.
Riba, just send your answer. minus 2 into r. R is 3. So on squaring, it will be 9 into 10 to the power minus 4. Density of water is 1000. Gravity is 10. Divide by 9 times eta, which is 0.05. So just neglect this decimal or remove this decimal to put 100. Now this 9 and 9 will cancel out. So this term and this term will cancel out. We have minus 4 plus 3 plus 1. So this term and this term will cancel out this term. So you're left with this 5. We'll divide this term to get 20. So it will be minus 40 meter per second. Just 1 minute, I have done a little mistake. At this point, on squaring 3 in 10 to the power minus 6, it will be 10 to the power minus 6. So this entire term will cancel out. Minus 2, r square will be 9 times 10 to the power minus 6, minus 3 into 2. Density of water is 3, gravity is 10, divide by 9, eta is 0.05. So if you remove this decimal, you will get 10 to the power 2 at this point. Now, just cancel out the common term. So this term and this term will cancel out. We have 10 to the power minus 6, 3, 1, 4, plus 2, 6. So you're left with 2 by 5 only. So it will be 0.4 meter per second only. Good, Atif. Mohammed Irfan, just check your calculation. Yusuf, any doubt?
No, sir.
Abhinav, is it clear to you till this part?
Yes, sir.
Okay, you all have written?
Yes, sir.
Okay, so let's stop here for today. In next class, we'll start the most important part of this particular chapter, that is Bernoulli's principle. Okay?
Yes, sir.
Okay then. Take care. Good night.
Thank you, sir. Good night.
Thank you.
Thank you.
Thank you. Yes, Mohammed Irfan, do you want to ask something?
No, sir.
Okay.